Everybody, my name's Jim White, and I am with EdgeX Foundry, the open source project, which I'm going to try and take you to a tutorial today. I am also the CTO of IOTech Systems, formerly at Dell, where we started this open source effort, EdgeX Foundry, which later became LF Edge, which is part of what the conference is all about today. So as co-founder of the project and as a technical chairman of the organization, I'll go as deep as you'd like today, but really what I wanted to try to do today from an agenda standpoint is to try to just give you an introduction to EdgeX Foundry, answer any questions you have, even do a quick demo to show you that in about 3 lines of terminal code, I can have you up and running with EdgeX Foundry and simulate data coming in from sensors and devices, get you up and going and start to experiment with that. So it's an easy on-ramp into learning a little bit about how EdgeX Foundry works and how you might be able to use that as part of your Edge or IoT solutions. Somebody who is sponsored by my company to be here, you've got to do the required pitch to say, hey, here's who I work for, IOTech. We're a software company. We provide a few software products, including a product we call Edge Expert, which is our if you will, commercial version of this particular open source effort, EdgeX Foundry. And then we provide some other capability as well, vendor neutral. And we work with a lot of different partners to really embed our solution as part of some of their IoT or Edge solutions. So again, my agenda, give you a little bit of background, give you a little bit of architecture about the projects, give you some information about how to use, how to work with and develop with EdgeX Foundry, essentially get enough to get you started. If you haven't had a chance yet to take a look at EdgeX Foundry, give you a little bit of background, but then give you a really easy on-ramp to using the system. What tools you'll need, what you need to get EdgeX Foundry, what you need to get up and running with EdgeX Foundry, and then I'll give you some tips on how to explore things. One of the quickest things we find to help people out is, how do I know it's actually up and running correctly, and what can you do to tell me that maybe something isn't working correctly? So I'll give you a little bit of tips and tricks of that area, where to learn some more, and then try again, answer any questions. And if you want to go deep dive, certainly can. This QR code that I've put up here is out to a YouTube video. We've done quite a few of these introductory types of sections in video form, and in fact, a lot of the content that I have today is immediately available from a YouTube video we did this summer. We call it Tech Talk, the series. So if you're feeling a little bit sluggish today and don't want to listen to me now and want to just kind of zone out and pick it up when you get home, plenty of opportunity to do that. Just scan that QR code and it'll take you right out to the same talk, essentially. Okay, so what is EdgeX Foundry? Open source, vendor neutral project. Of course, that would make sense since we're at a Linux Foundation event here. And importantly, also we call an ecosystem, meaning that we're more than just providing a platform, an open source platform for you to build IoT and Edge solutions. It's also a whole ecosystem of companies that are out there trying to put these solutions together. It's a resource to help do that. Obviously, through EdgeX Foundry, we're providing you a set of code, but you'll find, too, our community is just loaded with all sorts of expertise, as most open source efforts are. And so things like our Slack channel, things like our emailer forums and things of that nature have really been used to address all sorts of questions that go well beyond EdgeX Foundry. So please come and join our community. And I don't mean join in terms of contributing all sorts of money. It's an open group, but really a lot of expertise in helping to put together these solutions for all sorts of organizations. EdgeX Foundry is a microservice loosely coupled software framework. What the heck does that mean? I'll have a couple of slides in here that'll give a little bit more detail about that. But as a microservice architecture, one of the key ingredients to what we're trying to do is be extremely flexible to fit EdgeX into all sorts of existing environments, provide for a software framework that allows you to bring your own elements, your own secret sauce, if you will, add on top of it, take part of what we have, throw it away, add other ingredients. We're really trying to form what we call like an 80% solution to connecting up sensors and devices into your enterprise. Yep, we're not 100%. You're going to have to probably do a little bit of lifting there to provide some of the last pieces, and we'll talk about where that is. But the idea is to give you a starting point, to provide the meat and potatoes of your Edge environment. You add the ingredients that are your value add on top of that. We are hardware and OS agnostic, run on Linux, run on Windows, run on Mac OS, run on all the various OSs out there, run on ARM, run on Intel. We are actually working with a few organizations to run on the new RISC-V chips that are coming out. So we are really, truly trying to be as agnostic as possible. Something that's going to be easier out of the box than you'll find in other environments. You might have to do some building on your own. But what we're doing there is really trying to be agnostic with regard to architecture underneath the covers and OS underneath the covers. Of course, Linux Foundation project in Apache 2. What does that mean? For those of you not maybe as well aware of what open source licensing is all about, Apache 2 is what I call the business-friendly license. Take it, use it, do whatever you want with it. Never have to talk to us about it. Wish you would, but we have a lot of organizations that take it. And I just found an organization the other day who's got 45 developers working with EdgeX Foundry, been doing it for 5 years, probably know more about EdgeX Foundry at this point than I know. And they're out there doing things in complete secrecy. So you can do that. You can use EdgeX as you'd like, even build commercial products out of it. We're not going to stop you. We encourage you. We're there to help and provide that base platform. What you choose to do with it is completely up to you. And the Apache 2 license says that's OK. We started back in 2017 when I was at Dell. We were looking to try to find a way to build an open platform on our new Edge gateway hardware out there. We open sourced it through the Linux Foundation and started up a project with about 50 companies at the time. I was told by the Linux Foundation it was the largest starting open source effort at the time. I'm not sure that's true or not, but it was a pretty big effort. Today, we're, as part of the LF Edge, we're more than 70 organizations out there. Always provide our required mascot. Everybody has to have one of those today. Ours is Edgy, the octopus. Reason for that, if you know a little bit about octopus or octopi, I'm not even sure what the plural is, but if you know something about them, you will learn that not only do they have a brain, whatever looks like the head, but they also have kind of mini brains in the tentacles. And that's really what we built EdgeX Foundry to be that mini brain out there at the edge to operate, feel, sense, understand what's going on in the environment. Obviously, your cloud or your enterprise is that big head that has all those tentacles reaching out. And that's kind of representative of what we're trying to do with EdgeX Foundry. So EdgeX, put simply and non-glamorously, is middleware. It's edge middleware. Nobody thinks middleware is sexy anymore, I don't think. If you do, have I got a job for you? But it's middleware that fits between what is your operational technology and IT technology. So your cloud, your enterprise, your applications, your databases that operate and run in your organization. How do you get all those things in the operational technology world, speaking all sorts of different protocols, running on all sorts of little types of tiny and bigger devices? How do you get all that connected in and bringing that information into your enterprise, making it available to your enterprise? And oh, by the way, also offering a mechanism for you to, where allowed and desired, to actuate back down. So bring in the temperature data from your thermostat that allows some sort of intelligence to occur where you can also tell the thermostat to lower the temperature. And it's kind of its raw in essence. That's what EdgeX Foundry is all about, the middleware between those two worlds. Can't spell IoT without OT and IT, and that's really where EdgeX fits in. Again, we have a number of architectural tenets that the software is all about. I'm going to spare you reading the information on the slide, and this is kind of the mom and the apple pie part, but the important ingredients here, again, is to be extremely flexible. When we started to build this platform, we knew that there were going to be lots of different types of environments out there. There are going to be all sorts of existing capabilities out there. People were going to want to add their own elements in top, things like AI and ML. How do you do that in such a way that provides base, but allows people to extend, expand, replace pieces and parts as new technology comes in? That's why we've built EdgeX the way it is, a microservice architecture to provide for that flexibility, and then as well address a number of the concerns we saw in this space. Things like, hey, these devices are out there maybe on something like a shipping container or a rail car, so they're not always connected. How do you deal with that? How do you deal with technology that's been out there since 1979 and deal with that? Some of the bus protocols have been out there for a long, long time. Lots of different issues. If you've been involved in this environment before, you know and understand how do we start to address that. EdgeX Foundry is meant to try to provide for those kinds of environments. Got some words up here on the slide about how it works. I'm going to come back to these words. I'm a visual guy, and I find that sometimes dealing with the architecture is best done by trying to provide a bit of a picture, and then we'll come back to the words to try and fill in some of the gaps. This is EdgeX in all of its microservice glory. I know it's a bit of a crowded picture, but it's kind of our now famous or infamous, depending on which perspective you carry. Architectural diagram's been out there since day one when I started the project. At the bottom, to give you some orientation, this is that OT world. All of your sensors and devices that exist in your environment that you want to connect up, be able to talk to, get data from. Right? Could be anything from IP-based cameras to a Modbus device, backnet thermostat, you name it. We hope to and have in many cases talk to it. So that's the world, your OT world you're trying to connect. Up here, that's your enterprise, that's your cloud systems, your applications, whatever you're trying to get that data to, and wherever you want those applications or systems to be able to talk to eventually. Again, it may not always be two-way communication. Sometimes organizations say, whoa, I just want to suck the data off the edge. I don't want to actually allow anybody to come through my internet and change what's at the edge. We get that, but we do provide for the capability in both directions where you need to. Right? What's inside of this box then, the purple box, is all of EdgeX Foundry, all of its microservices that help provide for the solution we're going to see and work with here today. Yes, each one of these boxes is actually there today. I get a lot of questions, are all those there? Yes, they are. Are you going to need all those? Probably not. In fact, I would probably discourage you from bringing in the entire kit load of these services because some of it's just going to be things you don't need for your environment. Again, it's flexibility to allow you to use what you need for your environment and for your use case. Prime example of that, and we'll start kind of at the bottom, a collection of these microservices we have called device services connect your thing, that sensor, that device, into EdgeX. It speaks a protocol. If you have some sort of Bluetooth device that's going to speak BLE, you've got one of those thermostats again, you're going to do something like Modbus or BACnet. Those services communicate in the protocol choice with your particular sensor device. Do you need all of them? Probably not, unless you've got a real complex system. So you're going to pick and choose those type of services that you need. And then there are other services, things like this rules engine. We provide for a capability there, what we call our reference implementation, but could you bring your own? You want to bring in AI and ML and put it at the edge. Great. Not only do we encourage that, we actually provide an API set so that if you want to just drop it in place, it's real easy to do. So we'll talk about that. So from an architecture perspective, how does EdgeX work? Starting with the sensors or devices, as I mentioned, you have to have something out there that actually speaks the protocol that you want to communicate via with your sensor device, and it's going to start to get that data off of that device. That's the purpose of these device services, these microservices. At that point, once the microservice, the data, device service has that data, it will then ship that data up into what we call an application service. What are application services all about? As their name implies, they're going to start to communicate with your applications, your clouds, whatever the case might be. It can also simultaneously send this data off, optionally, to a core data service that's all about persisting the data at the edge if you need it to be there at the edge. Now, why would you need it to be there at the edge? Maybe this particular device that's out there at the edge is going to be intermittently connected. It doesn't connect to the cloud all the time. It's on a rail car, and as it goes in and out of tunnels and things, it needs to store that sensor data and then transmit when it's available with a connection. Or maybe you need that data locally because something out there is also going to use that data to make decisions locally, and it needs to take a look every once in a while into the back history to find out, well, if the temperature is 72 degrees right now, what was it an hour ago or 2 hours ago? Those kinds of environments are going to require you have that data at the edge. If you just want to stream the data on off to your cloud, your enterprise, great. Ignore this path. It's optional. Right? Once the data is in and up to that application services areas, as I mentioned, that set of services is all about getting data to your cloud or your enterprise. We built this on the premise of what is known as enterprise application integration, or EAI technology. For those of you who come from the enterprise, probably sounds familiar. It's pretty standard stuff. EAI is all about taking a set of data, doing any kind of transformation on that data, maybe doing something like compressing it, maybe doing something like filtering it, because not all data is that important. If the thermostat's reporting right now it's 72 degrees, and another minute from now it says it's still 72 degrees, do I need each and every one of those bits transmitted to the cloud? Maybe, maybe not, right? Application services do all that work. Transform, filter, get it into the right format. Maybe your application needs to be swizzled with its JSON just in a certain way. Application services do all that work, and then send that data off to your endpoint of choice. With the Foundry, we provide a number of what we call connectors to the various things like clouds, Azure, Amazon, used to be Google IoT Core. We won't talk about that anymore. But all the famous cloud providers, we also do just straight MQTT or REST. We get it to where you want it, when you want it, how you want it. That's the job of an application service. So now we've got all the data coming up from the edge, making its way up into your enterprise. But wait, there's more. At the same time, those application services are also preparing the data for, in our case, a local rules engine. We cooperate with another open source project out of LF Edge called eKuiper. It's a nice little rules engine. It does things like, 72 degrees in here, it's feeling a little chilly, I need to up the temperature. It will communicate down back through that same layer to communicate to actuate. But you don't have to use our implementation of this rules engine. You can bring in your own intelligence. You can provide AI, ML. The application services layer not only gets that data up into your cloud or your enterprise, it also prepares that data for whatever engine you want to use that data locally at the edge. Again, application services are just about preparing data to send it wherever you want. You can send it north, as well as it sending off to somebody else in the edge to have it do some work. So, so in addition to this capability of moving data northward and actuating back down and allowing you to provide for all sorts of additional intelligence at the edge, you'll notice there's a lot of other boxes there, right? We've got boxes out here to provide for security, protect the access into those services, provide for things like securing secrets at the edge. We provide capabilities, a little bit of capability at the management side, a little bit of experimental graphical user interface that most people are going to replace because you want to kind of customize that to your needs. But I'll show it to you, and it gives you at least a base, a foundation for building applications. And then a lot of what I call the ash and trash you're going to see in almost any kind of application, right? How do I send an alert? How do I schedule something to happen? Clean up of the database, or whatever the case might be. A lot of that capability is already baked in with additional services out there. All right, so I promised to go back to the words and fill in any kind of gaps here in terms of things like technology. So collection of a dozen plus microservices. No, you don't have to use them all. Use what you need, replace what you want. Each one of those boxes, each one of those services out there has an API associated with it. So if you don't like what we've done, think you have an improvement to it, replace it. All it has to do is live up to the same API, and away you go. Data flow, again, is device services into what we call our core services for things like local persistence, into application services where all the transformation and the formatting and what have you occurs. And yes, we provide for a reference implementation rules engine to show you an example of how to make some decisions at the edge, but it is just that, reference implementation. Do whatever you like there at the edge, and we can help to provide for getting that data to your smarts, to your IP at the edge. And then a lot of other services to provide for supporting capability. Each of the services has a REST API in place to allow you to communicate with it, understand its status, get metrics from it, you name it. Typical controls you're going to see of any kind of program, which is what each of those little microservices is all about. We also provide for message bus technology, the communication between all those services, or communication with things like devices or your cloud. Yes, you can do everything via REST, but we also have a message bus in place. So you can choose to use, for example, MQTT to communicate with a lot of the services, to communicate with your cloud, to communicate in some cases even with things like devices and sensors. So your choice about how you want communication to occur. We also do a little bit of work to provide for how you deploy and get things out there into your environment. We provide Docker containers for each one of the services. Yes, you can build and deploy the executables bare metal, do whatever you like with those executables, bundle them however you like. But we provide for containers and things like a Docker Compose and a Kubernetes Helm chart to get you on your way to getting EdgeX out to your production environment easier. Don't have to use that, but it's a nice way to get started, and I'm going to show you that here in just a bit. We also do things like work with Canonical, and so they provide Ubuntu snaps, if you're familiar with that environment. So you can deploy EdgeX in an Ubuntu snap environment with a simple click of a couple of buttons and pulling things down from the Snapcraft store out there. So a number of ways to get you started, but these are really provided for convenience. You can choose how to build and deploy EdgeX as you see fit. Questions so far? Putting you all to sleep already. All right. I know it's almost Miller time for the day, so I'm not going to go into a lot of details. There's some additional information about each of the different types of services, which I think I've already pretty much provided. But I will raise a couple of interesting things that can help you as well. Again, flexibility being the key, in particular around how you connect to your sensors and your devices, and then how you connect to things like your cloud or your enterprise. EdgeX is never going to know all the sensors and devices out there. It's never going to know all the protocols. It's never going to know and understand how you want everything sent to your particular cloud or your particular application. So what we provide in addition to baseline services are SDKs in this area. So if you'd like to build your own device service, provide a couple of versions of our SDK out there for you to do that. You're going to have some sensors that you've got a protocol invented by who knows what, who knows when. We're not going to know about that. So if you need that kind of connectivity and you want to build that yourself, the template is already there baked into our SDKs. We use a lot of open source ingredients. EdgeX, being an open source project, believes in open source, obviously. And there are a lot more of ingredients that I haven't listed up here. We use a lot of open source libraries and things in what we do. But some of the key ingredients, things like Redis is what we use for our database at the edge. By the way, that's been replaced a couple of times, so that gives you a pretty good assurance that you can change that out. If you're not a fan of Redis and you want to use some other database, we've used Mongo in the past. Over a Thanksgiving break a couple of years ago, I replaced it with SQLite. The interfaces are there, so you can do that. That's not work that EdgeX is going to do for you, but you can do it if you're the type who wants to get into the covers and try and make some changes to instrumentally use a different type of technology. We use Console for registration and configuration. Again, we use eKuiper as the rules engine. Kong and Vault are some of our security apparatuses out there. Clint just gave a talk right before this one about how we're looking at using things like OpenZD in place of or augmenting some of these services, and that's the type of thing we're doing all the time. Exploring how we can use better, stronger, faster open source capability or giving you more flexibility. When we started the project too, there's a lot of technology here that comes from the enterprise, comes from cloud native. This is Edge. And so we're always looking for how you maybe transform that a little bit. Take what was an enterprise technology, make it smaller, make it lighter, make it faster. Those involvements are coming all the time. EdgeX is always trying to follow up on that so that you don't have to. EdgeX is built so that you can deploy it all in one box. When I started off building EdgeX, it was about getting it to run on Dell hardware, on Dell gateways. Obviously, in that capacity, it was thought of as an application running on that one box. But we built it again to be flexible. And we know that your edge environments are going to be a heterogeneous environment of all sorts of components. Maybe a little Raspberry Pi connected to a device that then hooks up to maybe some sort of gateway that then hooks up to some sort of server. EdgeX can lay over the top of whatever resources you have, be it compute or network or what have you. So while we have all those device services and all the other services part of EdgeX, and I think about those often running on a box as I showed in the picture, you don't have to do that. In fact, we have many environments whereby things that connect to sensors and devices are out there running on one piece of equipment that talk to other services on another piece of equipment that maybe even talk to services running in the cloud. It is available to be distributed as you see fit. That does raise some complexities. You've got some security issues you have to work through, and things like firewalls and what have you. Again, some of the componentry is there to help negotiate that. It might mean you have to do a little bit more lifting there when it gets more complex, but as you would expect, as you get more distributed, you are going to have some elements where you're going to have to kind of work through, but the technology and the flexibility is there to allow you to do it. It has been done, by the way. All right, so time now to try to give you some evidence that getting EdgeX, getting it up and running is a pretty quick science experiment. Whether you do it or you want to go home to your engineers and say, hey, I saw this thing on EdgeX, give it a whirl. I want to give you confidence that in about 3 lines of terminal code, you can get EdgeX up and running. That's not to say you're going to get EdgeX up and running with all of your own sensors and devices and all of your clouds, but it's going to at least give you the confidence that you can get EdgeX up quickly and very quickly thereafter start to add in your own ingredients, all right? There are different paths of working with EdgeX. Different paths, therefore, of also bringing in the elements you want. There is a large portion of what we call our adopters. They don't want to really mess with code. They want a low code, no code, low drag approach to getting their edge put together. EdgeX provides that path. We provide you the materials, as I mentioned, to connect your things, give you some reference implementation to bring in some analytics at the edge. We provide all those ingredients, and we try to do that as quickly as possible. But maybe you want to do a little bit more. Hey, maybe you want to help us develop. We've got what we call a developer path for you. Get all the raw ingredients, help you build EdgeX from scratch, put it on your own hardware, maybe bare metal. Yep, there is a path for you as well. That's not one we're going to cover today, but it's out there. And if you've got a developer who is, I want to see everything at the bits and bytes levels and 1s and 0 levels, and some days I even skip the zeros, there is a path for them as well, all right? So know that the documentation is out there, and I'll point to that in a bit. And then there's an approach which I call the hybrid approach. There are pieces of EdgeX where you want to customize. You want to bring in your own sensor on occasion that we don't know about, or you want to maybe bring in your own intelligence, but everything else you want to use out of the box. That hybrid path is available to allow you to bring down EdgeX and then customize the bits you want while you use the rest of it as stock. That's a pretty common path, right? It's an adopter who's got a little bit more of an advanced need and has some capability to actually add some of their own elements. So we address each one of these paths out there. Again, we're going to focus in on, just with this demonstration, that adopter. You've found out about EdgeX. You want to give it a run. You want to try it out. And then from there, you'll make some decisions about, do I need it as it is? Do I need to make some additions to it? So adopter pulls and runs EdgeX. We're going to do that via Docker containers. Don't have to use those, but that's a pretty common path, especially to get started. You're going to change some small amounts of configuration. You may do some tweaking at the edge, like do things like add rules into our rules engine. I don't consider that a coding or hybrid path, right? We've already provided for those operations where you can make those small changes without having to write a line of code, just making some small configuration changes. So it doesn't require coding, doesn't require building anything. You don't even need the tools to do that. A simple editor in many cases will allow you to do those kind of things, and I'll show you that. Again, other paths, hybrid developer paths, if you want to use snaps as opposed to the Docker container path, which I'll show you, documentation out there to do all of that. And rather than trying to learn all of those nasty URLs, I'll make it real simple for you. EdgeX Foundry is the project name, so edgexfoundry.org. Throw a docs in front of that, and you're going to find we've got, I think, some outstanding documentation, especially for an open source effort out there. So go out to that page. There's a search bar in there, say hybrid or developer path, and it'll take you to all these pages that I've got listed here. So really quick and easy way to get into and learn more about the project. And I'll bring some of that back up at the end of this discussion as well. Okay, so what do you need to get started if you want to use EdgeX as an adopter? Well, you're going to need a platform to run it. Yeah, I know I said you could run it in a distributed mode, but let's keep it simple. Let's just try and drop it onto a box and run it quickly on something like a Raspberry Pi or something like your laptop, whatever the case there might be. You're going to need at least 1 gig of memory, about 32 gigs of storage. Again, we run on Intel, we run on ARM, your choice. That we don't care about. Those numbers, can they get lower than that? Yeah, again, remember that picture where I said, well, you're going to choose the services you want. We're going to start off with the assumption you need all the services and work back from there. So you can make it smaller. You don't need as many resources as are listed. Our target has always been the fact that we want EdgeX to be able to run on a minimal Raspberry Pi at the very least. And we have, and many companies often do, run it on smaller things than that. Once you've got your host platform, what else will you need? In this particular get started quick environment, you're going to need Docker and Docker Compose running on your environment. Those are real easy to set up. If you don't know how to do that, your developers, your community out there that you work with can point you to some things in the Docker documentation to get you up literally in less than 5 minutes. You'll need some sort of editor, TextPad, Notepad, whatever the case might be, if you need to make some changes or tweak some of the environments. Again, not coding, just making some small configuration changes. And I'll actually show you some of the tools that are already there with EdgeX that allow you to do some of that without even having an editor. You're going to want a browser or some way to make communication calls in and out of EdgeX just to test things, see the data, understand that things are up and running. By the way, if you don't want to use a browser, you want to use curl, or you want to use some sort of tool like Postman, something that can make REST calls is what you need. And again, all of this can be found in our documentation. So if you're talking to one of your developers at home, say, hey, I want you to try this out. Go check it out, take a look. Just point them again to docs, edgexfoundry.org, and all this information is available out there. How do you get started? I'm going to take you through this actually here in just a second, but just kind of a listing of the instructions you're going to need. You're going to need what we call the Docker Compose file for EdgeX. What is that? So Docker container environment, I'm going to take the assumption that everybody has heard of or at least understands the basis of Docker. Docker Compose essentially is a way to, in a what's called a manifest file, to say, here's all the containers I want to run, and here's how I want them to be able to communicate and talk to each other. That Docker Compose file is that manifest, and EdgeX Foundry gives you that Docker Compose file. In fact, we actually give you many options for that Docker Compose file, again, based on what services you might need, what version of EdgeX you want to use. We've got a new release that just came out, and I have this bit.ly address pointing to the latest and greatest EdgeX Compose file. So we'll use that URL to go pull down the latest and greatest manifest file for EdgeX and get up and running here in a matter of seconds. There is a whole list of these Compose files out there. I'll actually show you that website here in just a second, where you can choose if you want to start to choose a particular version or options included, so you can get a sense that there are all sorts of ways you can get started with EdgeX without having to know all about all the ingredients. Once you've got that Compose file, you need to run it. One-line command has you up and running with EdgeX. Give it about, depending on the size of your network, if you're at the airport, everybody else is out at the airport, might take you a few more minutes, but if you're at home, it's probably going to take you less than 5 minutes to pull all of EdgeX and get it up and running. Right? And then once you've got it up and running, you're going to want to make sure that it actually is running well, or at least running as best you can. There's a simple command to do that. We'll show you that. But then there's all sorts of other ingredients about how do I know it's running correctly? How do I know it's pulling in data? Things of that nature. Okay. By the way, there's been a couple. If you are familiar with Docker Compose, for those who do a little bit of Docker work, recently Docker Compose made some changes. So some of our documentation is still working its way through some updates. Docker Compose used to be a Docker-Compose tool. And for reasons that still confound me, they decided to remove the dash. So all those fancy scripts and everything I have are still broken as I'm replacing the Docker-Compose with Docker Compose. So I'm sure you'll see me make that mistake here at least once here today. All right. So let me actually show you how this works so you can really give your developers, your community, or you yourself the assurances with these 3 commands, we can be up and running in very short and quick order. Okay? And by the way, for those of you who are visually impaired like me, there's the phonetically spelled out means of how to get things up and running. I've got everything you need in this one file, bit.ly edgex ONES, and then the rest of the command. All right, so let's see if the demo gods are with us today. Let's see, can everybody see that? Nah, it's probably a little bit shy, isn't it? So let me bring this in here a little bit. And let's zoom in. Is that pretty good? Those in the cheap seats in the back, everybody can see that? Okay, so again, the first command that we want to run is that command to pull down the Docker Compose file. I'm just using curl here. You could go out and browse to get the raw Docker Compose file from our repositories, and there's all sorts of documentation. It'll take you quickly there as well. But just using curl to go out and get at this bit.ly address, which again is just pointing to our EdgeX repository, to get the latest and greatest Docker Compose file, which I just made available with this edgex-ones, asking it to bring that down, put it in a file called docker-compose YML for YAML. Right? Again, you could do this in a number of ways, but this is a quick and easy, down and dirty way to do that. So I'm going to do that. So I've got that file. If you didn't know anything about Docker Compose, again, Docker Compose file is a YAML file, and I can show you a little bit about what that looks like. It's a little ugly. Oh, that's not very readable, is it? And this is not a class in how to do Docker Compose file or YAML, but what I want to do is just kind of give you an indication of what I mentioned, that this is a manifest file. It just provides all the ingredients about which types of service. For example, the app service rules microservice is going to need this particular container image off of Docker Hub. Here's the port it's going to use, all sorts of configuration, right? It's just a manifest of all the things you need to run, all the services, the microservices you need from EdgeX, how they all fit together. As you become sophisticated and start to do more to customize EdgeX, this will be a file that you'll probably be going into to help to change things for your environment. Remove stuff from, add stuff to. Once you start to figure out how EdgeX is going to overlay in your environment, that's what's going to be needed. Okay, so now I've got that Docker Compose file. To get EdgeX up and running with Docker, I'm going to do a docker no-compose up-d. All right, now I've cheated a little bit because I already went out and had it pull all the containers. Normally that would take a period of about 5 to 10 minutes depending on your network. Yours is running, so Clint beat me. All right, so it doesn't take much, all right, to pull it. As you can see in this case, start it. By pull, what I mean is Docker Compose communicates with Docker Hub, goes out and grabs all those EdgeX Foundry containers that we've already got built and prepared for you out there in Docker Hub, brought all those services down and starts them up. Based on that manifest file, it knows how to talk to each other. And it's actually mimicking the sensor data already. We provide a little service in there we call the device virtual. What is device virtual? Device virtual is a service that mimics any type of sensor you'd like to. Just randomly generates, floats, integers, that kind of thing. All right, so whatever you need in terms of data, it's now shooting that data out and producing that inside of that EdgeX environment, which we've got. All right. Yeah, you're going to want to connect regular sensors eventually, but this helps you get you going. Lastly, if you don't believe it's up and running, you can do a process stat, which essentially says, hey, is everything up and running? And you could start to then bring up the environment, which means, oops, sorry, come on, system. Bring up things like the user interface. Yes, there's a user interface provided nominally with EdgeX. It's a nice little tool. It's not maybe what you want in the end, but it's a little user interface to show you what services are running and actually start to explore that data that's produced out there. So I can go to the data center here and say, let me see that data that's being streamed from my sensors or devices. Again, it's a virtual device, but up and running you are, and you can actually see that data now coming in EdgeX, and you can actually start to export that out to your cloud or your enterprise or whatever you'd like. All right? So down and dirty, provide the means to see EdgeX up and running. Let me just one last thing here, kind of wrap it up with, hey, I want to learn more about EdgeX. I want to do more, start to learn how I can do some things on my own here. Docs, Slack channel, YouTube channel. We actually have our own channel out there on YouTube, so there's a lot more videos. Code and social media, all available online, quick and easy way to get up and running. Questions?
Sorry, we can do questions.
Okay. I've been told I'm kicked out. I'll take questions down the hall. Thanks, everybody. Thanks for your time and patience.